The next measures of location that we are going to learn are quartiles and percentiles. Quartiles are the set of values which has 3 points dividing the data set into 4 identical parts. For an ungrouped data, quartiles can be identified by quartiles are organized into lower quartiles, median quartiles, and upper quartiles. Now let's try to find the first, second, and third quartile of the given data. First, we need to rearrange the given data in ascending or descending order to find quartile. Since n equals to 7, 1/4 of 7 will be 1.75. Note that r is not an integer. To find the first quartile, we need to round up r to the nearest integer, which is 2. This means first quartile is the second data. And the second data is 3. Therefore, first quartile of this data is 3. To find the second quartile, we have to check the second quarter observation, which is 3.5. Note that r is again not an integer. Rounding off r to the nearest integer will give us 4. The fourth observation of this data is 5. So the second quartile or median of this data is 5. To find the third quartile, we have to check the 3/4 observation, which is 5.25. Rounding off r to the nearest integer will give us 6. The sixth observation of this data is 10. So the third quartile of this data is 10. Now let's try the next example. I hope all of you remember to rearrange the given data in ascending or descending order. The number of data in this example is 12. We need to find the 1/4 of the data to find the first quartile. 1/4 of the data is 3. Note that the value of r is an integer. For the case where r is integer, we will take the mean value of the third and fourth observation. So the first quartile of this data is 6.5. To find the second quartile, 2/4 of the data is 6. Again, we are getting r as an integer. Since r is integer, we will take the mean value of the 6th and 7th observation. So the second quartile of this data is 9.5.
To find the third quartile, 3/4 of the data is 9. The mean value of the 9th and 10th observation is 17. So the third quartile of this data is 17.
This slide explains on percentile of an ungrouped data. Percentiles are the values that divides the distribution into 100 equal parts. Percentile of an ungrouped data can be calculated as below. It is important to know the difference in finding percentile for the r value when r is an integer and r is not an integer. Let's try to find P10, P16, and P21 of the following data. To find percentile of a given data, first we need to rearrange the data in ascending or descending order. Next, to find P10, we first need to find 10 over 100 of the data. 10 over 100 of the data is 3. Next, we need to check if we are getting an integer value of non-integer value. Since it's an integer value, P10 is the mean of the third and the fourth observation of the data. Therefore P10 is 5.5. Next, to find P16, we first need to find 16 over 100 of the data. 16 over 100 of the data is 4.8. Now we need to check if we are getting an integer value or a non-integer value. Since it's a non-integer value, we need to round up to the next integer, which is 5. So P16 is the fifth observation of this data, which is 7. Therefore P16 is 7. The last question is to find P21. We start with finding the 21 over 100 of the data. 21 over 100 of the data is 6.3. This is a non-integer value. Rounding up the value to the next integer will be 7. So P21 is the 7th observation, which is 17. In this lesson we will be learning how to plot and interpret box and whisker. A box plot summarizes data using the median, quartiles, and the extreme, least and greatest, values. It is used to provide a graphical display of the center and variation of a data set. To plot box and whisker we need to know the value of quartile 1, 2, and 3. We also must know the maximum and minimum value of the data. Else than that we must also find out the upper and lower fence using the given formula. Last we need to identify outliers if any. When the whiskers are the same length on the left and right, and the median is the center of the box, we say this is a symmetrical distribution. Note that Q2 minus Q1 is the same as Q3 minus Q2. When the left whiskers is shorter than the right whiskers, and the median is nearer to Q1, we say this is a skewed to the right or a positively skewed distribution. Note that Q2 minus Q1 is smaller than Q3 minus Q2. When the left whiskers is longer than the right whiskers and the median is nearer to Q3, we say this is a skewed to the left or negatively skewed distribution. Note that Q2 minus Q1 is larger than Q3 minus Q2. Now let's try to draw a box and whisker plots for the above table and give comments on this distribution. The total number of students is 48. 1/4 of this data is at 12th observation. But since this is an integer we have to find the mean of 12th and 13th observation which is 2. Therefore Q1 equals to 2. To find Q2 we will take 2/4 of the data which is 24th observation. Since this is an integer we have to find the mean of 24th and 25th observation which is 3. Therefore Q2 equals to 3. To find Q3 we will take 3/4 of the data which is the 36th observation. Since this is an integer we have to find the mean of 36th and 37th observation which is 4.5. Therefore Q3 equals to 4.5. Next find upper fence using the given formula. Upper fence of this data is 8.25. Find the lower fence using the given formula. Lower fence of this data is -1.75. From the table, we can see that there is a data outside the upper fence 8.25. This data is known as an outlier. Outlier of this data is 9. The diagram below is a box whisker plot. The data is positively skewed since the whisker on the right is longer. Q3 minus Q2 is greater than Q2 minus Q1. There is an outlier. 9. I hope all of you are able to find and interpret the mean, mode, median, quartiles and percentiles for ungrouped data. Construct and interpret box and whisker plots for ungrouped data.